Okay, let's try lesson 2.8 example 1 together. There was no solutions in the notes. So we're given f as a function. It's a discrete and finite function. It has only 3 ordered pairs in it. We're just asked to find f of 1, f inverse of 5, f inverse of f of 1, and f inverse of f of 3. I guess the first question is just a bit of a review of function notation. F is defined as yielding an output of 5 when our input is 1. One thing I want to point out is that we don't need the inverse to evaluate all of these. If you ask me what is the output from the inverse when the input is 5, I understand that to mean what is the input from the original that will give me an output of 5. I just need to make sure it doesn't happen in any other way. So without writing out what the inverse is, I feel comfortable saying that f inverse of 5 is definitely going to be at least 1, and I'll check and make sure if there are any other options. I think for the next two questions, I might find it a little bit easier to have the inverse written out. So what I'll do is I'll just record what the inverse is. Let's review that inverting is an exchange of domain and range. The result of that is that you basically swap your inputs and your outputs. Independent values become dependent, and dependent values become independent. So that would be a set of ordered pairs that would be members of the family for f inverse. And this will help me out for this expression right here. I wish I had a letter for it. Let's figure out what f inverse of f of 1 is. I think I'll start on the inside and figure out what f of 1 is. F of 1 is 5. And then I take the number 5 and I treat it as an input into the inverse relationship. When I input 5 into f inverse will output 1. Easy enough. Now just be very careful in assuming that this f inverse and this f just eliminate or cancel each other. This is not always the case. We'll see that to be true in this last example here. If you asked me to evaluate f inverse of f of 3, I would figure out the output from the original when my input is 3. The original machine labeled f gives an output of 7 when the input is 3. And now into the inverse, I'm going to substitute in 7. Well, this is another case where on the original function, there are 2 different inputs that give me the same output, and that's okay. That doesn't break the rule of being a function at all. But that means that for the inverse, there will be 2 similar inputs that give me 2 different outputs, and that breaks our rule of a function. F inverse is not a function. So when I try substituting in one of these special inputs, it will give me 2 possible outputs, and I need to list both of them. That causes more concerns in some of your future examples. This is where your sketches will come in super handy. Try that out.